Glenn, as the host, you can mute everyone.
Okay. Some more folks joining us here. Okay, I think we'll go ahead and get things started here. I imagine we'll still have some other folks joining us as we get moving along here. Thank you so much for coming along tonight. Having a brief talk tonight about the new piece that is being premiered by the Northern Lights Choir here in Saranac Lake, New York, up in the Adirondacks, and with Helen DeMung as the director. And it's a piece called "The Cry of the Hunger Stones," and it's very much a tone poem, kind of a musical picture of this amazing record of climate science that has recently been researched, mostly in Eastern European rivers, but in some other parts of Europe as well. So I'm going to switch over to a screen share here, so we can take a look at some pictures of this place. Okay, so so the piece is called "Cry of the Hunger Stones." Okay, there's been some interesting new research out there that has uncovered these marvelous markers of climate change in European rivers. As a composer, I'm interested in taking some of the data, some of the scientific end of these things, and converting that into a musical expression. The process is called sonification, and I'll be talking a little more specifically about that later. Okay, but everyone needs to know that this sort of thing is only possible because of musicians like those in the Northern Lights Choir and Helen DeMung, who directs them, and also only possible with the help of the New York State Council on the Arts and the folks up here at the Adirondack Lake Center for the Arts that fund these sorts of things that enrich arts in communities all across the state here. So please be on the lookout for other good stuff like this, funded by NISCA and your local arts councils. Here in this picture, you can see that excuse me, we have a couple more folks joining us here. Okay, good, thank you. Here in this initial, oh my goodness, here, let me get back to okay, I am going to shift back a little bit here. No, not sure why I am getting this. If anyone has some advice here on how to get rid of this window here in the okay, hold on just a sec here. Okay. Let's try this again. Okay, we're back in business here now. So if you notice here in this first image, there's some German words that are written upside down in this stone. I want you to remember those because we are going to be talking about the translation of those words a little bit later. Those words become the lyrics that the choir will be singing here on Friday. So the particular hunger stones we're focusing on tonight, they're in the town of Děčín in the Czech Republic. It's along the Elbe River, okay, just on the northern part of the country, very close to Germany, okay, and here you see in this image, okay, the Elbe going through the middle of town, okay, with on one side we have this rather imposing small mountain. On the other side, we have a hill with a lovely aristocratic palace and a tower on it. I want you to remember that tower here as we look at the next couple of images. Since, of course, the river runs right straight through this small town, it has been, of course, it has been the lifeblood of this city since the Middle Ages or before. So if we are looking at that same tower, okay, over here on the left, you see it, and we see the tower over here. That's the same place, okay. One with a rather striking drought, and the other with a rather striking flood. The Elbe River is a brutal river to this small town of Děčín. And much of the history revolves around its ebb and flow, and it's documented in many interesting ways here, including paintings like this that show both the floods happening, and then while the flood is happening, this triggers fire in the town. Okay. And as well as in more modern times, if you visit Děčín, all around the town, there are these markers. Here on the left-hand side, you see this line that goes up the corner of a building. Well, that's a measurement of the level of water that is happening at any given time. Also here on this pier that holds up one of the bridges, we have that same marker. Okay, so the measurement of the up and down of the Elbe River is embedded in not only the history but also the imagination and the very architecture of Děčín. Paula and I got to visit Děčín last May, and spent a wonderful day with Libor Elledor, who's a hydrologist who's studying these hunger stones and taking this data coming from the stones and aggregating it with other information, some of it coming from climate science, some of it coming from literature, okay, from paintings, from all sorts of things. He's just a marvelous mind of combining these various things to try to pull it all together into a complete picture of the droughts and the floods in this town. Now, when you look at Elledor here, he is gesturing toward this stone right here. Okay, and this stone you can see is is actually kind of protected by a little wall that has been built by the city, because this is one of the hunger stones. Okay, this is a stone that when we visited last May, the water was at this level. Okay, however, if you walk up to the edge of it, you can start to see that there were some things inscribed in that stone. On the right is a picture of that very same stone when the water level is much lower. So, so what we find here in Dechin is this mix of water levels. So, some of them drought levels, some of them flood levels, but largely going back to the late 1500s, we have folks taking stones that are alongside the river, okay, carving a line like this that I'm pointing out with the cursor, and then in and around that line, they would carve in the date that was the water level on that date. Okay, so it's an astonishing amount of climate data, okay, linked to specific dates that again, as I said, go back to the 16th century, and Libor has been trying to aggregate all of this sort of thing. If we walk across the bridge and over to the other side of the Elbe, we get this rather imposing stone, okay, underneath that tower that I showed you earlier. And here we have these flood markings, okay? So we get a sense of the scale, okay? The flood or the river is still down down here below the level of the feet of these fellows here, okay? And then we get a sense of this little square image right here. We also get a sense of some lines that are carved all the way up into this area, okay? And here's a detail on the right of that square area that has been carved with various dates in it, okay? These dates, of course, are marking flood stones, okay, not drought stone or flood levels. I'm sorry. These are flood stones marking flood levels, okay, not drought levels. One of the most interesting things in spending the day with Libor is that he said that part of his research was actually going through all of these dates, both the flood levels and the drought levels, and figuring out which ones were frauds. Okay, because he would find out that a certain date carved into the stone with a level on it, well, the script used for the numbers would not be a script that would have been used until 100 years later, right? And so he was able to actually sort out these fraudulent markers and hone down into those that were actually authentic to the best of what he could figure out. Here's a 1682 mark right there. Okay, that was not a fraudulent one. That was a real one. Okay. Also down at the base of this large boulder, there were several carvings like this one. Okay, and it has a sort of a code attached to it. Okay, that Libor was able to explain. Okay, that you know, right now, okay, this is a little bit above the current level of the Elbe, and what he was saying was that in the date that this was carved in, the level of the water, okay, was 9. Okay, there's a value there. That's a 9. This is a 5, right? The E represents largely the estimation of the distance between your fingertips and your elbow. Okay, so there were 9 of those units, okay, above the water, and then what's hidden here behind the grass, okay, were 5 hand.
Yeah.
Okay, Really fascinating ways in which Libor has had to use a whole bunch of disciplines, a whole bunch of different ways of thinking, and using medieval measurements. He's a really cool guy, and we had a great time. I walked away from that day thinking I should have gotten 3 college credits for it.
Oh,
So what Libor has been able to do is to gather together all of these levels, okay, of both the drought and the flood levels here in these stones in and around Dechin in the Elbe River. So what is a musician to do here? Okay, it's certainly a common practice going back into classical music, into folk music, into all sorts of ethnic musics, in which we as creators, we'll look at a river, right? And we as creators, we have a response to that river. We have an individual response, an emotional response, that sort of thing, okay? And out of that, we will write a piece of music, okay? Here in the Czech Republic, we have great examples of this, okay? Bedřich Smetana wrote this amazing musical picture, this tone poem called the Moldau, okay, which is an orchestral piece of music that paints a picture of the beginning of that river, okay, as it grows, right, throughout its meandering around the country. And actually the Moldau has become one of the great sort of musical symbols of the country of the Czech Republic. However, when Smetana did that, okay, he, as a composer, he looks at the Moldau and he writes music that responds to it, right? That's one beautiful way to write music. I write music that way sometimes too, but sonification is a different way of doing it. Sonification actually seeks to have a kind of an empirical connection between the notes that are played and the subject of the piece. So this is not a crazy newfangled idea. Okay, this is an idea that's been around a long time. And of course, yes, I know this is a short talk, but we have to go all the way back to the ancient Greeks. Okay, I promise we will fast forward and get to the modern day. Okay, before the end of the talk, but the mathematician, theoretician, philosopher Pythagoras, in addition to tormenting 10th grade math students on their New York State Regents exams each year with the Pythagorean theorem, he had much more to say than just that. Okay, he had larger ideas than just what a triangle is. He had this notion that all is number. Everything is number. Everything can be expressed in numbers. Okay. Now, before we get lost too much in the past, okay, all of you know that every time you go to the doctor, okay, when they take your blood pressure, well, what are they doing? They're taking the movement of your blood through your veins and they're turning it into a number. Take your temperature, okay, they're taking the heat of your body, turning it into a number. Okay, we always turn things into numbers. We're actually very accustomed to that. Actually, we're even a little bit worried about that these days with big data and AI, that everything can be manipulated numerically. But in doing that, we're actually hearkening back to this wonderful old notion that Pythagoras had, that everything can be expressed in numbers. He had a couple of really interesting parsing outs of this idea. Okay, one of which he says, if you just had numbers by themselves, you get arithmetic. Okay, we get that in elementary school math classes. But also Pythagoras said, if you took numbers and you put it in space, now you get geometry. That's understandable, right? Okay. Pythagoras also says if you put numbers in time, he says that's when you get music. How about that? Okay. And then the most marvelous notion, okay, is this ancient Greek notion that if you put numbers in space and time, you get astronomy. It's hearkening back to this philosophical notion that all the things that move out in that move in the night sky, okay, those parts of the heavens that move around, move in this kind of harmonious mathematical rhythm, okay, that they call the music of the spheres. Okay, so this connection between music and numbers is a very deep and ancient one for us. If we fast forward just a little bit in that ancient Greek world, Aristotle and folks around his time, they gave us this other really interesting notion where where everything in the universe, okay, has two qualities to it. Its essence and its accidents. Everything has an essence, which means it's the unchangeable thing, the eternal part of that thing. And then the accidents is the moving and changing expression of the essence. Okay, so for me, okay, right now on Zoom, okay, you are looking at the 50-ish version, okay, of what Glenn is, okay. When I was 7 or 8 years old, I was still Glenn. The essence of me was the some essence of my 7 or 8-year-oldness still exists today, but the expression of that has changed. Okay, from a 7 or 8 year old skinny little kid, okay, to a slightly paunchy, slightly balding middle-aged white guy, right? Okay. Okay, so the essence remains the same, but the accidents changes. And of course, what this means is that if we go back to Pythagoras, well, what is a right triangle? Okay, I just use the words right triangle. That's an expression of that particular shape, right? I could draw a picture of that, you know, and that would be another expression of right triangleness. If I do a squared plus b squared equals c squared, that's another expression of the essence of right triangleness, right? But each different accident has its own purposes as we do things. So this is what brings us into how sonification works. Okay, in my musical composition process, what we do, okay, is use a very simple version of modular mathematics that takes a bunch of numbers that are generated by a scientist that's measuring something, and turning those numbers into melodies and harmonies. Okay, so we go back to our drought and our floodstones. Libor has translated all of that into tables of data, into water levels going back to the 16th century. Well, what do? Okay, simple processes. Okay, that you take the highest value of all those measurements and the lowest value, and you figure out what's between them. That's called the range. Okay, and in my case, I'm going to write a piece of music that's based on a do re mi scale. Okay, do re mi scale has 7 notes in it. Do re mi fa sol la ti, right? But do is just another version of do. So we're going to say that we're going to work with the 7 notes of the do re mi scale. So what happens? You take that range, okay, that mathematical difference between the highest and lowest, and divide it up into 7 equal chunks. 7 equal intervals. Okay, so for example, if the highest number in your data set was 70 and the lowest was 1, okay, well, then you would divide that up into 7 equal chunks. Well, 1 to 10 would be 1 chunk, 11 to 20 would be another chunk, 21 to 30, and so forth until you get up to 70. Then you go back to your data and gee, oh, here's a data point, which is 23. Okay, so that would be that would fall into that third chunk. And as soon as it falls into that module, into that chunk, that's now going to be aligned with one of those notes, one of those 7 notes of the scale. So any data point that happens between 1 and 10 would be do. Any data point that falls in 11 to 20 would be re. Any data point that falls from 21 to 30 would be mi, and so forth. Okay. And so what happens is that in that way, we start to take these data points and those generate notes. Okay. And if you have just one list of numbers, you get a melody. If you have parallel data points, or data sets rather, okay, which happens in all sorts of sciences, well, you sonify each one of those data sets, and now you have multiple melodies playing at the same time, which means that you get harmony. Scientists read data sets both horizontally and vertically. Musicians read data sets both horizontally and vertically as well. Okay, for musicians, the horizontal data set is the melody. The vertical data set is the harmony of multiple instruments playing together. In the case of the way that I approach sonification, I use this to generate the core melodies and harmonies of a piece. Okay, there's other folks in the sonification business that do that use this process in a more pure kind of way. Okay, where every single note in the piece comes from sonification. For me, I just use it to create that core information, and then I do the normal composer work after that, taking that melody and writing a piece that tells a musical story in some sort of way. So I asked you to remember those German words written upside down on that stone in the first slide. Well, those words written in the hunger stone, which means it's one of the drought stones. Those words are "Wenn du siehst mich, dann weine," okay, which translates to "when you see me." Okay, so it's the stone that is speaking here in this piece of writing. When you see me, the stone, then cry. Because the notion is, if the water level is that low, then there is so much drought, okay, that means we're going to have failing crops, and we're going to have a lot of hunger. Okay, hence the name of the hunger stones. In the piece of music that the Northern Lights Choir will perform on Friday night, okay, we use these words as the words that we sing, and we use these words as sort of a palette to draw this musical picture of the piece on top of it. And of course, when it comes to the Weine, okay, which means cry, okay, there's some moments in the piece where when the musical parts of the piece have faded away, and all we're left with is this sort of raw cry. Okay, it's a shouting cry, it's an angry cry, it's a desperate cry. Okay, but then there's also the following of that with almost a whimpering cry before the water comes back in to the piece. So this is this is what's happening on Friday night. If you happen to be up near the Adirondacks, certainly I'll be getting a recording of the piece and sharing that online through my website and through Facebook and Instagram and that sort of thing. So some other examples of this of some of the sonification work that I've done, okay, includes some stuff I've done with the European Space Agency and with their Rosetta mission. Okay, there's some YouTube videos up for that. And I I just find it as a composer a really exciting place to work, an exciting creative space to work in, for a bunch of reasons. I think that that on one hand, when I'm writing music with scientists that are doing research, I'm always writing music with really cool, fun, interesting people. Okay. And I love being around cool, fun, interesting people that teach me new stuff. And sonification sort of has that built into the process of hanging out with great scientists and thinkers. But also, I think there's a real powerful opportunity, I think, here for creators of music, not only classical musicians, but also musicians of other music styles to become part of the public dialogue about science. Okay, to enter into this world that needs a whole lot more dialogue, needs a whole lot more understanding of both on the empirical scientific level, as well as the emotional embrace of what these things mean, and the exploration of that meaning. I think we as musical creators have a chance to enter into that dialogue as we confront some of the biggest things that are in front of us these days with climate change and other environmental challenges that we all share. Okay, no matter who we are. So that's what I have to say here. We have just a couple minutes before we finish up, about 5 left here. If anyone wants to put a question in the chat here, I would be happy to respond, to try to answer it.
Hi, Glenn. It's Pia here.
Oh, hello.
Okay, so Gary is here too, so we're coming to you from the mathy end of things. So the question is, why 7 and not 12?
Well, there's just simply different strategies of doing it. Okay, just as a scientist has to decide what scale that they're going to use for the visual graph. Okay, the composer using sonification uses the various musical scales. Okay, so if we're dealing with if we want to create music that's based on a do re mi scale, then we're using that mod 7 or mod 8, okay, depending on if you want to include the octave.
Yeah.
But of course you can take that same set of data and divide it up into 11 or 12 if you want to use the chromatic scale, which is really fun actually to run the different calculations and see what music comes out of the same set of data.
Okay, we can get fancier too, can't we? With some of the enharmonic things and stuff like that. But I'll mute now. Thank you, Glenn. This is wonderful.
Yeah, and actually, if we bring in our colleagues from places in the world like India, okay, there's a much more complex sonification palette available with microtones and things like that. It's such a marvelous new creative world to navigate around in. Any other thoughts or questions here before we finish up tonight? Well, great. Thank you everyone for coming in and joining here tonight. Again, another big thank you to Helen DeMung and the Northern Lights Choir, and to the Adirondack Lake Center for the Arts and NISCA for supporting this kind of work. And we'll be posting some of this stuff on my website as well as Facebook and Instagram as we start to get recordings and those kinds of things. So thank you everyone for coming out tonight, and look forward to seeing you with future projects. Thank you.
Night, Glenn. Thank you.
Yeah.
Thanks, Glenn.
Yeah. Bye-bye.
Bye-bye.
Bye, Glenn.
Okay. Bye-bye. Yeah.
Let's see, I'll stay around. Go away. They're not going away. They want to talk.